Question number 35 of NSEP 2022, and question is: a small sphere of mass 2 gram is released from rest in a large cylindrical vessel filled with oil. The resistive force due to viscosity of oil acting on sphere is proportional to its velocity. Sphere approaches a terminal speed 5 cm per second. The time it takes the sphere to reach 90% of its terminal velocity is approximately, and these are the options. So, dear students, we know that suppose this is a sphere and weight should be in this direction, and due to viscosity, resistive force should be in this direction, and we know that mg minus viscous force, it should be equal to mass into acceleration, and mg minus viscous force is directly proportional to velocity, or we can say viscous force, we can take a proportional coefficient bv. So mg minus bv, that should be equal to ma is dv upon dt. So equation becomes mg minus bv, mg minus b into v equal to m dv upon dt. It should be equation number 1, where this b is a constant. And we know that at terminal velocity, acceleration should be equal to 0. There should be no acceleration, or we can say that if it should be 0, mg minus bv equal to 0, or now when dv upon dt equal to 0, then this velocity becomes terminal velocity. This velocity becomes terminal velocity, or we can say terminal velocity is equal to mg upon b. This is equation number 2. Now we solve equation 1 and 2, and we know that mg from equation 1. First I derive the formula for we will solve the relation between velocity and terminal velocity. So from equation first, we solve equation first is mg minus bv equal to m dv upon dt, and we can write dt equal to m dv upon mg minus bv. Now integrate both sides, and we can write t equal to integration of dt is t, m is constant, dv upon mg minus dv, it should be integration of dv upon mg minus bv log mg minus bv base e divided by the differentiation of this term, and it should be minus b, plus a integral coefficient constant c. And we know that at initially t is equal to 0, velocity of the sphere should be equal to 0. So put the value of t and v in above equation, so it becomes 0 equal to minus m upon b log mg to the base e, this term is 0, plus c, and c equal to m upon b log mg base e. Put the value of this c in this equation. So t becomes t equal to minus m upon b log mg minus bv to the base e plus m upon b log mg to the base e, and t becomes t equal to m upon b log or minus m upon b log mg minus bv upon mg base e, or minus bt upon m, minus bt upon m equal to log mg upon mg 1 minus bv upon mg base e. Now if we take the integration, antilog, so it becomes 1 minus bv upon mg equal to e to the power minus bt upon m. This is the antilog, or we can write 1 minus e to the power minus bt upon m equal to bv upon mg. And we know that in equation number 2, mg upon b is equal to the terminal velocity, mg upon b. So mg upon b, b upon mg, it should be 1 upon vt, v upon vt. So v equal to vt 1 minus e to the power minus bt upon m, minus bt upon m, and m upon b may be represented by tau only for the representation. So v equal to vt 1 minus e to the power minus t upon tau. This is equation number 3. So if you know this formula, then you can use directly in the numerical problem. Now we will put the value and it becomes m is I think 2 gram. M is 2 gram. 2 means 2 into 10 to the power minus 3 kilogram in MK system. G is 9.8 meter per second square, and terminal velocity, I think it is terminal velocity is 5 centimeter per second, or we can write Vt is 5 centimeter, means 10 to the power minus 2 meter per second. And if we put the value in this term, Vt equal to mg upon b, so b equal to mg upon Vt, and now we can find the value of b. M is 2 into 10 to the power minus 3, g is 9.8 upon Vt is 5 into 10 to the power minus 2, and if we solve it, it becomes 0.392 kilogram per second. This is value of b. And similarly we can calculate the value of tau, that is m upon b. M is 2 into 10 to the power minus 3 and b is 0.392. After solving it, it becomes 5.1 into 10 to the power minus 3, and it should be in second. Now we know that in question it is given that velocity is time it takes the sphere to reach 90% of its terminal velocity. So it is given in question that velocity is 90%, 0.9 of the terminal velocity, 90 upon 100, 0.9 upon terminal velocity. And now if we put the velocity in equation number 3, then it becomes equation number 3, we can write v upon Vt equal to 1 minus e to the power t upon tau, and v upon Vt becomes 0.9 from this equation. So 0.9 equal to 1 minus e to the upon tau minus t upon tau, and e to the power minus t upon tau equal to 1 minus 0.9, or we can say 0.1. Now, so e to the power t upon becomes 1 upon 0.1, that is 10, and if we take log, then t upon tau equal to log 10 to the base e, and t equal to tau log 10 to the base e, and t equal to tau we have already calculated 5.1 into 10 to the power minus 3, and log 10 base e is 2.3. If we solve it, it becomes 11.7 meter per second, or we can say that the answer should be D. Answer should be D. Thank you.